Linux. In this nugget, I'm going to attempt to address everything that I possibly can about using the Linux operating system. And since this is not a Linux course, of course, this won't be comprehensive, but it's important to at least get started with this if you're not familiar with Linux already. First, we'll take a look at a basic overview of Linux and some of the key features of it and why people might want to use it, especially for hacking. And then also some key items about how to use it. There are certain things that you type in within Linux that won't work within Windows and vice versa. So you need to get used to a little bit of a change in the way we do certain things if you're coming from a Windows environment. Also, we'll take a look at some of the key commands or the most commonly used commands from within Linux, things such as how to use various commands for file management, for example. And we'll also take a look at how to work with user accounts, how to create user accounts, modify, or delete user accounts from both the command line as well as the user interface. Finally, we'll take a look at applications. There's a few different ways of installing applications, but we'll see here when we get to this portion, we'll demonstrate using the Red Hat Package Manager to install applications from within a Red Hat operating system. Let's take a look at why we would want to use Linux for hacking purposes. First of all, really it's just kind of the de facto hackers platform. Now, a lot of hackers these days are also migrating to Windows or using Windows more. It's just that Linux gives a lot more flexibility. Of course, you have flexibility with other operating systems too, such as Macintosh, or Mac X, or you also have that flexibility with Windows. You can change the appearance of the colors and all that different kind of stuff. That's not what I'm talking about, though. With Linux, you have the capability of, if you want to go this far, go into the operating system itself and make pretty serious changes or coming up with your own distribution of Linux. You can write your own operating system if you want. No, not a lot of people do that. Typically, we simply use something that somebody else or another company has already come up with on their own, but that's really the whole point, that Linux is very flexible, and a number of companies have their own different flavors of Linux and give you different advantages to the different flavors. Small versions of Linux, which just give you kind of a bare bones operating system without any graphical user interface, small bare bones versions can fit on a floppy disk, and you can run it from there. So a lot of flexibility with the hackers platforms. The other thing there is that most hackers programs originate with a Linux or a Unix background, and of course Linux is just another flavor of Unix. Well, most of those hackers' tools get their start on a Linux platform. Now, many times later on, they're ported over to Windows, but even if there's a Windows equivalent, much of the time the Linux version will have added features or more flexibility to it than the Windows version. Let's take a look at another reason why a lot of people like Linux, and that, of course, is that it's free. I mean, why pay for something that you can get for free? Now, a lot of times you do still pay for Linux. You can get it free if you want to, but if you do something like download the Red Hat version of Linux, yeah, it is free and it's freely distributed from their website. But if you want to get continuing support or technical support for their version of Linux, then you do have to pay for it. It's like on a subscription basis. Of course, there are other versions of Linux as well. SUSE Linux, which I mentioned a little while ago, Debian, a number of different other platforms of Linux. In any case, you can get them, just about all of them, for free. And if you do have to pay for something, usually it's just some kind of a support plan that you have to pay for. At the time of this recording, it's still the most popular version of Linux is probably a Red Hat version. And Red Hat allows free downloads of their cutting-edge, latest versions of Red Hat through their Red Hat Fedora program. Just go to redhat.com and you'll check that out. Also, like I said before, kind of up here when I was talking earlier, Linux is very, very flexible. You can use the GUI if you want to, or you can use simply a command line only. A lot of server administration can be done using a command line only, and a lot of Linux hacks out there, people who had their origins in Unix, where they didn't have a GUI anyway. And you can get a GUI on a lot of different operating systems, even in Unix these days, but a lot of people in their background have just the command line interface, or the CLI. Also, with Linux, we have the capability of compiling programs. You can use things such as the make command, for example. That's M-A-K-E, to compile your own programs. Whereas with a lot of Windows programs, you don't really get the capability of getting down into the compiler itself unless you have the source code and that sort of thing. Well, it's a lot more difficult to get into Windows programs than it is to Linux programs. And that, by the way, is another reason why a lot of viruses are created on and packaged on Linux platforms, because these hackers will find a virus, or at least the main idea of a virus, and then they'll open it up and they'll modify it to their own purposes, recompile it, name it as a different virus, and that's why we have different strains of viruses out there, is because of the compiling capability. One thing you want to keep in mind, by the way, in terms of what I just mentioned, which is viruses and also spyware, is that there's not that much good protection for viruses or spyware on the Linux platform. If you use Microsoft products like Windows XP, of course you get Microsoft's own anti-spyware. You can probably see that down here in the lower right corner. There's a little target. I don't know why they use a target. That means, attack me and try to shoot me or something. But in any case, that's Microsoft's anti-spyware, which at this point in time is still free. And here, by the way, is just an anti-spyware notice that I got from that product. And I'll just go ahead and mention it while it's here. It just notifies me that something's tried to change my start menu from from a blank page to cbtnuggets.com. The reason why it does that, and I'm going to allow that, the reason why it does that is because a lot of spyware tries to change your home page. Well, this kind of software would stop that. Well, in Linux, you don't really have that. There's not really a well-known version of any kind of anti-spyware software that works really well, and it's even more true with virus protection software as well. Now, there's some kind of homegrown versions of both of these, but there's nothing that's got the backing of large companies such as Symantec and Microsoft and that kind of thing. Well, when it comes to actually using Linux, I'm going to kind of approach this from the perspective of a Windows person who's typically used to using Windows operating systems and kind of getting their feet wet with Linux. And as we do that, let's first of all address startup issues. When you turn on the power of the computer, in older or more fundamental versions of Linux, it doesn't usually go right to a desktop of some kind with something like a start menu, kind of an equivalent, or mouse controller, that kind of thing. Typically what it really does is it goes to a command line interface, or a CLI. In order to get a GUI, you have to run start X, and at that point it'll launch a desktop of some kind depending on what your choices are. You can choose from multiple different kinds of interfaces, such as using GNOME or KDE or certain other ones that are available to you. So this is what Linux typically looks like as you get started here. So once we get to our interface here with Red Hat, after we have booted in, we need to go ahead and, or boot it up, we need to go ahead and log in here. And I'm going to just log in as the root account in this case, which again is the equivalent of your high-level administrator account in Windows. And then I'll enter in a password. And once we do that, we'll go ahead and get started, and we just wind up at a command prompt. Now, you can do a lot of Linux administration from a command prompt, but for most purposes these days, even some hardcore Linux guys are now going to just using some kind of a UI instead, or user interface. So I'll just type start X, which starts the X server here, and then it loads up a desktop for us that we can use the mouse with, and it just looks a little bit more fun to work with. And so you can see here then that we've now booted into a Red Hat 9 desktop, and despite the fact that we're in a UI now, a lot of what we'll still be doing will still be done at the command line interface. So in order to get there, you need to get to a terminal window, and there's an item down here in this version of Red Hat that has a terminal item. So you simply click on that item, and then it will open up a terminal for you, rather a command line interface terminal for you, and then you can just perform whatever commands it is that you need to do. If you don't have a terminal item directly on that part of your console down here at the bottom, actually not called a console, it's called a panel. They call this whole thing down here collectively kind of a panel. Then what you can also do is simply access it from the start menu here as well. And you simply go to System Tools and then go over here to Terminal. And then what you can also do is to configure the panel to include that item right down there. And if I remember right, that's actually how I got mine on that one. Now this again is a little bit of an older version of Red Hat, but still quite commonly in use. Here's a more current version of Red Hat, and with this version, as soon as you boot up the operating system, it takes you right to a GUI, or user interface. So I'll just log in. And it doesn't take me to a CLI first, where I have to log in a text-based way and then start X to get my server desktop going here. Now here, as long as I'm going to this version of Linux, let me just go ahead and launch a terminal here. Notice that I don't have one down here. These are all the Office kinds of applications. For openoffice.org, you can get kind of free versions here of word processors and presentation software, and kind of equivalents to Microsoft Office products. But in any case, I'll right-click here and choose New Terminal, because it's now on the right-click menu in the current version of Red Hat Linux. Very easy to get to. To make basic file browsing easy, what you do is you simply do a dir. You can do this works in Windows as well as within Linux, although in Red Hat it only works in more current version of Red Hat. Notice when I do a dir initially, however, nothing appears. Well, if I do a dir -a, then I get all files that appear here. However, if you're going to work with Linux, I suggest that you use the Linux version for accessing your files from the command line, and that would be using ls instead. And if I do an ls, just similar to my first dir command there, it didn't do anything, but an ls-a or -a shows me all of these files, and it makes it a little bit more clear because the blue things right here are going to be directories, whereas the black things are actually files. To get around in our file system, I can do a cd to the root of the file system or the top of the file system, but instead of using a backslash like we would within Windows or a Microsoft operating system, we'll do a / instead. Now when I do an ls, it takes me to it shows me that I am at the top of the file system here in Linux. Another important thing to keep in mind is that it is case sensitive. I just ran into this recently, for example. When I couldn't get my desktop to load here, it kept giving me an error message stating that the resolution was wrong or words to that effect. Well, I needed to get to a config file here that's in the etc directory. So if I simply cd to etc here, and then I can do an ls here again, then it shows me a lot of these different files that are available to us. Again, it shows me a lot of different files, directories, and so forth. The file I was looking for here, however, was an x11 file. Let's see if I can see it here. There it is. The x11 directory is what it actually is. So I did this. I did a cd to x11. No such. Why does it tell me no such file or directory? There it is. I see it right there. There's a directory. So do it again. CD x11. Don't change anything. You just type it over and over and over again, and you get this scrolling down here. Well, the key here is in Linux, it's case sensitive. If I can use my mouse right, it's case sensitive. So notice that is actually a capital X. So CD capital X 11. And now I'm in that directory, and I can ls again, and I see additional files here. And the file I had to use for my video resolution was an ceh05 config. And what had happened was I had made a change in another desktop that I'm working with, another Linux desktop. And after I'd made the change, my video didn't work anymore. When you do make a change to a lot of things, by the way, in Linux, it will often create backup files. And in fact, in that particular system, it created an ceh05 config .backup file. So I simply copied that file over the top of my existing working file, and I was back in business again. All right, now you can see here I've cleared the screen. By the way, I guess I should show you how I do that. If you got a screen full of gibberish like this, it's just kind of cluttered and everything, you want to clear it all off, type the word clear. Not CLS like we do in Windows, but the full word clear, and then it will clear up the screen for you. But in any case, let's say, for example, I want to copy this file. How would I do that? Basic file management from a command line here. Well, I don't type the word copy in Linux. I type the word CP. So CP and then XF. And here's a quick tip for you as well. You type in the beginning of it and then press the tab key on the keyboard. Automatically fills in the rest. Now notice that there's another file that begins XF here. There's two files actually. And one of those is XF config 86 config dot. Well, if I hit a dot here, then that's unique to this file only, and tab would then fill in the rest of it for me there as well. So you just type in as much as is unique for a specific file name, and it'll fill in the rest for you. And then I would type in the destination for my copy command here. This is the file I'm copying. And then my destination, this is very similar to Windows for the rest of this, would be wherever I want it to go. So for example, I want a home directory for my trainer account, which is where I'm logged in right now. And this would be xf86 config dot back for backup, for example. And press enter, and now that's where it would get me. If I wanted to change to that directory to confirm that it's there, I'll do home, T for trainer, tab again, and it'll automatically fill in the rest. And now if I do an ls, I notice that my file is indeed there. And by the way, before I forget, CD does change directories just like it does in Windows, but again, we use forward slashes here. I can't seem to use my mouse here for some reason. We use forward slashes here instead of backslashes like we might in Windows. All right, if I wanted to then go ahead and how about rename this file? How would I do that? What I would do here then is I would actually use the move command, and we can do this a couple of different ways. I can actually move a file physically from one location to the next by typing mv, or I use the same command if I want to just rename it. So xf, fill in the rest, and then I wanted to remove that to maybe the same location, but I want to name it according to the date. Then that might be xf86 config dot. And my current date is, I think it's 01, what is it, 12th, I think it is, 06 at the current time. Okay, so I can do something like that, and now I've got the file renamed to the current date. I got a little ahead of myself here. Let's go back to our whiteboard here. So remember that using Linux, we are working with a case-sensitive operating system. For file management, you can use CP to copy. You can use RM, by the way, to remove. And you can use MV to move a file. Let's go ahead and take a look at that RM command because I didn't show you that one yet. What if I'm tired of this file and I don't need a backup and I say, hey, I'm going to fly by the seat of my pants. I don't need any backup files. Well, then what I could do here would be to RM ceh05 the rest of that file by pressing tab and press enter, and now I've deleted that file. And then to simply exit out of a terminal window if you don't need it anymore, simply type the word exit and press enter, and it takes you back where you need to be. By the way, a lot of what I've shown you there from the command line is just what Linux folks do. They're used to it. They like that. But to kind of make the transition easier, when we have a desktop operating system with the UI here, we also have this item right here, whatever the name of the user is, home, and that takes them right to their home directory, similar to how you can have home directories from within Windows as well. And if I hadn't deleted that file, we would still see that there. But we can go, you can get kind of familiar tools here, similar to what we have in Windows. You can click on up, and you can see other directories. Notice the big red X-looking thing here. That's not my directory, so therefore I don't have permission to access it. So if I try to double-click on it, of course, I can't do that. I mean, I do, but it doesn't show me anything in there because it's all concealed from me. I can continue to go up through the file system until I get to the top, and we can see here that, again, there will be various directories that I don't have any kind of access to. One thing we do have access to, by the way, there will be the TMP directory, or temp directory. All users have access to the temp directory, and they can just kind of throw scratch files in there for files they've downloaded and want to perhaps share with other people and stuff like that. No sooner do I close that than I realize I should probably explain what some of those directories are that we just saw there. So let me go back to where we were here. Some of these directories here, kind of useful just to know what they're for and what their purpose is here. So let's go ahead and address these, not all of these, but a lot of the key ones here, starting with this bind directory. And this is where we have commonly used binary executables. So for example, if I were to double click on that, then we would be able to see things such as, oh, how about this ls command that I just used a little while ago? Ls command to list things? Well, there it is. Commonly used directories that just about all of our users would need to be able to access. Other things that we would have would be the boot files. Here are boot files that are important for properly booting up the operating system. We also have things such as the dev directory. This is going to have one file for every device on the system. For example, if I have a CD-ROM or any other kinds of device or hardware, all of those things are going to appear for me in this directory somewhere. All my hard drives, ATA drives, those kinds of things will all appear there. In Linux operating systems, it's a little bit different because everything is actually represented in a file. Even your physical hardware is actually represented in a file. Not quite the same as a driver that we have in Windows, but it is represented by file. Then there's an etc. This is going to be our system configuration files, where we'll have different things that are necessary for the system to be able to operate properly. We'll also have lib directory here. This is going to be where we have shared program libraries, similar to how we have DLLs from within Windows. You may also have an opt directory. This is where we can install optional software. So if we add additional programs, they'll be installed in OPT, or at least that's the conventional place where we'll go ahead and put those in. And this is the MNT directory. This is where we can mount removable media. So if I go into this, we see that we have CD-ROM, floppy disk, for example. That's where we can mount those. And in order to access the CD-ROM, for example, it has to be mounted to this CD-ROM item right here. Now, I don't have a CD-ROM in there, so of course I don't see anything right now. Other things that we'll have here then will be the proc directory, or this is where it shows our processes that are in use. There's also the root directory. This is where we're going to have the root user's home directory. It does not appear in the same home directory as everybody else. This is where our generic users go. This is our privileged root user account, and where that person's files will go. Similar to how we typically do not log into Windows systems as the administrator account, we don't always log into the Linux systems as the root account, but we can always switch users to the root account to perform privileged functions if we need to. All right, let's go ahead and take a look also at sbind. This is where we're going to have system administrator utilities that we don't want generic users to be able to access, too powerful or too security sensitive, for example. And then there's a TMP directory where we can just kind of, any user can write any files into this temporary files directory. And there's also a VAR directory here. This is variable data such as log files, users' mail files. These are files that will change frequently that we'll need to be able to access and read. And then there's also the USR directory. This is going to be a user directory that has user-specific resources. So that gives us some idea of how to manage files and what some of the key directories are. Let's also take a look at text editors. A lot of the key configuration files from within Linux are not binary files, they're just text files that the operating system reads through to figure out how you want to do what you want to do. For example, I mentioned a little while ago that I have video in a text file, and if I do an ls here, remember, I had that ceh05 config file. Well, you might be thinking, I wonder what that really has in it. How do I see what's in that file without necessarily needing to edit it, just to read it? Well, remember within Windows, we'd use type, and then we type followed by the name of the command. Here in Windows, rather in Linux, boy, the Linux people would hate me for saying that. What we'll do instead is to type more, followed by the name of the file, cef86config, and press enter. Notice that it shows me how much of the file I've read so far. I've read 2% of it when I get to this point. I can go down one line at a time by pressing enter, and then I can also go down a whole page at a time by pressing the space bar. Now, if I've read everything I need to read, and I don't really need to go anywhere else, I see, the resolutions that are available for this and everything. Then what I could do is just press Q if I want to get out of this early without going all the way to the end of the file, and then you can see that it returns me simply to the flashing cursor command prompt here, command line. So that's pretty much it for getting to just look at the information without necessarily needing to edit it. Let's show another text editor here that we can actually use to edit and write text, and that would be something like a very fundamental tool called cat. Cat followed by a greater than sign followed by the name of the file you want, James file, for example. And then here I'm actually at an editing command line that I can use. So I'll just type in whatever text I think is appropriate. How about short, bald guys are cool and sexy. That doesn't mean I'm attracted to short, bald guys. That means I am one. Okay, the more I try to think about that, the worse the explanation gets. So in any case, I just better save this file right now. In order to do that, I'm going to hold down Control and press the D key on my keyboard, and then that would then save that file once I've pressed enter there. So after I press enter, Control D, saves the file. If I want to confirm that, of course we have our more command, and I can type in more James file, and we see that that text file is indeed as I typed it in. Now, if you have something else that you want to append to that file, if I just did something like this, cat, and then double greater than sign, and then the name of that file that I was looking for there, and press enter, then what I would do is simply continue to type. Let me, and sizzling, something like that. Press enter, and then again my Control D. Now when I do my more command here again, then I see that it has now appended that data to the original file. Another text editor I could use would be VI, and I'll just type VI followed by the name of the file that I want to edit, and we open this up, and here's my file that I was working with here. Now, a lot of text editors just move your cursor over where you want and you start typing. Well, that doesn't really work here within VI. So what I have to do is to go into insert mode, and I can press the insert key or the letter I on the keyboard. That takes me into insert mode, and I can now start typing in whatever I want to type in. If I want to get out of insert mode now and to save the file or something like that, don't go to File Save As, because there is no such thing. Look at this. This relates only to the terminal window, not to the word processor that I'm actually using here. To get to commands where I can save files and exit VI and that kind of thing, I'll press the escape key on the keyboard, and then we can follow that with a colon. And notice that I now have a colon down here at the bottom of the screen, and then I can follow that with whatever command I want. For example, W would just write it to the disk, and then I would stay within VI to continue to make editing changes. If I did not want to make any changes and I just want to get out of here without saving the changes, Q exclamation point. If I want to just quickly get out of here and save the file, then what I could do is to simply type capital ZZ, both caps, ZZ like that, and now it saved the file and exited VI very quickly. If I want to view the file to confirm that I've got the changes there, then again I can just do more James file, and now we see that it indeed did save those changes. Finally, there's another text editor that I can use, and that's Emacs, which is another very popular tool for text editing. And then I can just, again, type Emacs James file in this case, and there's my file. Now, notice this is a lot more like the traditional notepad that you might be used to using or other small text editors. It gives you a print command. You can save it. You can open directories and so forth. And the menu system up here is relative to this actual software application. So then, I could just move my cursor down here and enter in more information. No. Looks a little like I'm overcompensating there, but anyway. So in any case, you type in the words that you want, and then in order to exit out of this, what I would do is I can use the file menu system over here, which also gives the keyboard shortcuts, which a lot of Unix guys like to use. So I'll just use the keyboard shortcut, which is Control X, and then C, and then that would exit, and it prompts me to save the file here as well if I want, so I'll type in Y for yes. Now if I do a more James file, then we see that it indeed did save those changes. Now that just gets us started with a lot of these text editors. With just about any of the command line commands you need, or these text editors, or a lot of those different things, you can look to the man in order to find out any additional help. You know, in Windows, you type in the name of the command followed by a space / question mark. In Linux, what you do is you use the man command. So if I wanted to learn more about VI, for example, I'd type in man, which stands for the manual page. Then I would type in man, VI, and then it gives me a whole bunch of different stuff. You know, I can look at all this stuff about how to use VI. Now, another important command to be aware of is the PS command, which allows us to access or identify which processes are currently running. In Windows, we'd right-click on the taskbar and choose Task Manager, which would show us that information. Here, we'll just type PS, and it shows us a few commands that are running, but it doesn't actually show us all of the commands that are running. So if you want to see all of them, you'll do a PS minus capital A, and that shows you all the processes that are running. Now, why do you want to see this information? Well, a couple of reasons. Number one, you might have, remember we're having high-profile machines here that are susceptible to attacks being turned back on us. So I might want to see if there's a keystroke logger running or something like that, or see if there's some spyware or a virus that someone has infected my machine with. Well, that might show up in the process list here. Other reasons might simply be practical reasons. Maybe I've got a browser that's hung up. Maybe it's got a web application that's trying to run, and it's just hung up and it's not closing properly. Well, let me go ahead and launch the Mozilla web browser here, for example. And if I do now a PS while I'm launching that Mozilla web browser, we'll go ahead and see then, finally it comes up, there it is, we'll see then that we do have Mozilla running here. Now if I take a look at this again with a PS minus A, like I mentioned earlier, kind of follow my own advice and use a capital, then we do see it down here at the bottom, and it's process number 12,198. Now, it's not always that easy to find this. You might have dozens and dozens of different processes running, and fortunately, it just kind of showed up down at the bottom of the list for me here. But if you need to see more specifically, find out where it is, you can also use the grep command, which I can type the pipe key in here, which is the same key as the / key, only with a shift, and then I can do grep, and then in Mozilla, and then it would show me that specific process. Now, what I want to do here is to kill it. So if it's hung up or something like that, or it's causing a problem, or maybe it doesn't have a UI where there's no X in the upper right corner, or no file close, or that kind of thing, what I can do then is to kill, and then a -15. Now, what's the number mean? A -15 would allow the program to go through its normal processes, and it would clean up its log file. It would clean up after itself, and it would close itself, pretty similar to what it would do if you did click on an X in the upper right-hand corner. So that's kind of a graceful shutdown. If it's being a stubborn program and it won't close with a -15, then you might have to be less graceful and do a -9, which just kills it without a chance for any kind of cleanup. It's just kind of more of an emergency shutdown kind of an idea. Then you'll follow this with the number of the process, which, what was that? 121998. And enter, and now we see on the down here at the bottom, we don't have that browser running anymore because we have successfully killed it. Let's address another thing you'll need to be acquainted with as well, and that is the network configuration for your Linux box. As we go into Linux here, we'll see that there's not really a network neighborhood on the desktop where you right-click and choose properties like you could in some versions of Windows. Instead, what we can do is a couple of different things. One thing we can do is to right-click on the desktop and, again, go to a terminal. And once we're in a terminal, we could type ifconfig, but watch what happens when I do this right now. ifconfig. And it says command not found. Now, some of you Windows folks might be looking at that and saying, well, that's right, James, you typed it in wrong. It's ipconfig, not ifconfig. Well, hold on there, smarty pants. Remember, we're in Linux. And in Linux, it really is ifconfig. The problem here is, one of the problems is I'm not in the right directory. So, what I'm going to do here then is to change directories to the sbin directory. And then if I ls here, we see that there is indeed an ifconfig. So there. So in any case, now watch what happens when I type in ifconfig. I'm in that directory, right? If I type in pwd, that shows me what working directory I'm in. Yep, I'm in sbin. So ifconfig, crap, still not there. What in the world is going on? Well, there's a couple of issues. Number one, if even when you're in the directory where the command is found, in Windows, you can just type the command. In Linux, even when you're in the correct directory, you have to type in /ifconfig. I press enter. Now I get the information that I need. It's kind of wacky, but that's the way it is. Now, another thing you'll want to know about is how to change your IP address. And I guess I went ahead and cleared the screen a little too early here. So let me again do an ifconfig, and we'll identify a couple of things. Number one, what's our current IP address? Well, it's 10.10.10.70 that we can see right here. What's our current Ethernet adapter ID within Linux? It's ETH0, and since it uses ordinal numbering there, that's identified as our first Ethernet adapter. So in order to change this address, I would do a /ifconfig, because again, I need to do that even if I'm in the proper directory. And then I would enter in the identifier for this network card, and then the new IP address that I want it to have. Let's say 10.10.10.71. Now, watch what happens when I press enter here. And permission denied. Well, why is that? Because I'm not the root account. So I need to switch users here and enter in the correct password for the root account. Once I've done that, then, I can go ahead and enter in a new IP address like I attempted to do a moment ago. So now I'll simply repeat the command and press enter, and now we see that it is indeed got the proper address. Now let's go ahead and do this as well. We can confirm that we've gotten the correct address by pressing enter again after typing in the ifconfig change items right up here. But look what happens. Look, it still says .70. Well, didn't I just change that to 71? Yes, I did. But what you may have to do is to bring the network adapter down and then bring it back up again. And in order to do this, you can do an if down, which is interface down. And then once you've brought it down, then you follow that command with an if up to bring the interface back up again. It's kind of like just rebooting the network adapter only. And then once you've done that, you should be back in business with your new IP address. Now you might be thinking to yourself, well, James, why don't you just show us IF down and IF up? Because I know it's not going to work right. Let me just give you, since you're going to be working with VMware a lot and you might be transferring virtual machines from one machine to the next, let me give you a quick tip with this one in terms of working with VMware. And this is a rare situation in which something does not quite work right. You see, since I brought this from another computer, it had a different MAC address, and when I brought it into this system, it had the old MAC address, but on new hardware here, because the MAC addresses are randomly generated by VMware. In any case, even though I can still communicate on the network, there's certain network issues that could come up because the hardware address is going to be different. Let me show you a different interface to use as well, and I'll kind of kill two birds with one stone. A different interface to show you network properties, and that would be neat. I could type neat and press enter, and it would open up the interface that I want, but I'm going to follow this with neat and then an ampersand right here. And why do I do that? Because that'll bring up the interface that I'm interested in working with, and it will also leave open the terminal in the background. You see, I can go back and forth between this network configuration here and this background item right here, and I could do, any kind of commands that I wanted to do. Whereas if I had not entered in the ampersand afterwards, this terminal would be kind of locked up, so to speak, and I couldn't type any new commands in there. In any case, if I wanted to change the IP or the MAC address for this device, I would go into the Devices tab from my network configuration, which is what we got by typing neat, and then I would double-click on that active item, go to the Hardware Device tab, and you can see that right here it gives us a MAC address, but that's really the old MAC address from a previous machine that I had originally installed this virtual machine on. But if I click on Probe, then it looks at the MAC address for its own local machine at this time, and watch what happens. Notice that it changed that item right away. Now, because of screen resolution issues, we can't really see the OK button down here, but there's my OK button right where my mouse pointer is. I can see enough of it to click on it. And then what I could do here now is I could deactivate and then reactivate it, similar to using IF down and IF up from the command line. In that case, I'll go ahead and I could deactivate it, but again, right now it doesn't have record of that MAC address being different yet, because I have not yet okayed this dialog box either. So it asks me now if I want to save my changes. Here, when I go ahead and say yes, and click OK, now it will go ahead and give me those changes that are necessary. So now I could also then again deactivate it. Now you see that it worked correctly. Then I activate it, and because I've got the correct MAC address in play right now, everything is just fine. So now let's go ahead and review some of the Linux commands that I've used as we go here. I thought I'd just go ahead and put this together to kind of summarize some of those. Remember, ls is similar to dir in Windows. It shows me a directory listing if you want to see all of them. Follow it with a -cap a. And then you can also switch users to the root account by typing an su from a command line. And of course, you have to know the password. If you want to change a password, I don't think we went to this one, but if you want to change a password, just type PASSWD, and then it'll prompt you to type in and confirm a new password. Then there's also PS, which we use to look at running processes. And then remember that PS minus capital A will also show you all processes as well. There's also the grep command, which we can use. It's not really a command by itself. You use it in conjunction with commands such as PS. And you can use it to kind of filter your results. You can kill processes with the kill command. And remember that we use kill followed by a -15 for a graceful shutdown of whatever that application is. And if it won't go down gracefully, you can use a -I to be more forceful about it. Then there's also the pwd command, which you saw me type in, and that simply shows you what your current working directory is, just to confirm that. Now, of course, as you work with Linux, you're going to need to work with multiple user accounts. So we need to get a little bit of a primer here on user management. Now, remember, as I've mentioned many times before, the root account is the highest level administrative account in Linux. So as a result, it's a security-sensitive account, and you don't usually want to log on as the root account to your desktop unless you have to, for some reason, to perform an administrative function. Likewise, even when you're at a command line, you don't want to do root-level functions, and you only need to switch users to the root account if you need to. So as a result, you're going to need to be able to create and manage additional accounts to perform just generic everyday tasks. This is also important if you're going to compromise somebody else's machine. You don't want to log on as the root account because it's likely that when people comb their logs and people that are sensitive to security issues and actually look at the logs, which isn't very many people, but whoever does that, you want them to just kind of glance over generic user account activity because they're probably looking for something that happens as the root account. So we want to be able to just add users, and we also want to be able to at times delete users because you might want to cover your tracks and get rid of user accounts that you've created and you don't want people to notice them. And you might also want to just modify the properties of a user account. Now these are all command line functions. There's also a graphical user interface if you're using a Linux desktop. Let's first of all, though, go ahead and take a look at how to work with these user accounts using the command line. Now then, to create this account, I'm going to go ahead and go to a terminal. Right-click here and choose New Terminal. Of course, I got to switch users to the root account because it's security sensitive to work with and manage and create user accounts. So I'm going to create this account using the root account, and I'm just going to type in here user add, and I'll enter in the name of the person I want to create. Let's do Tony, for example. Now, here's an error. If you're familiar with Linux, you notice that I'm typing something in wrong, and I'm doing this on purpose. Notice that as soon as I press enter, it says invalid username Tony. Well, we're used to typing in the capital letter for the first name of people here, for the first letter, and that's what we could do in Windows. But in Linux, it does not accept capital letters for the username, so I have to enter in all lowercase. Now, once I enter in user add with the lowercase Tony, we'll see that it creates the account successfully. One thing to keep in mind, however, is that Tony does not have a password. Now, that doesn't mean he can log on with a blank password. It just means he can't log on at all. So in order to give him logon credentials, we'll need to fix that as well. So we'll just do passwd Tony, and then we'll enter in, press enter, and then we'll enter in the password that we want for this particular user, and then we'll repeat it, then he'll have a password. So I simply enter and repeat the password, and it says all authentication tokens updated successfully, which basically is telling us that the password has now been changed. Now this user could log on with whatever password I typed in there. By the way, if you do try to change the password to something too simple, watch what happens here. If I just enter password of, password, then it says it's based on a dictionary word, or it can also give you other messages saying it's too short, and so forth. So I'm just going to kind of quit out of this and get out of it. So in any case, it does keep in mind security and good security measures for entering in the password properly. Now, another thing I might want to do here is to just look at the basic usage of some of these commands. And with some Linux commands, you can do that. For example, we worked with user add earlier. If I just type that without any parameters, then it shows me all the various options that I can use. Same with user mod, which I can use to change the account. For example, if I want to user mod -g, and I want to change the group to users for the Tony account, then I just type in the syntax exactly like you see it there. Let me also point out that these do have a graphical user interface equivalent if you go up to System Settings, and then Users and Groups down here at the bottom. I'll have to, of course, enter in the password for the root. And then it allows me to manage these user accounts. For example, there's my Tony account. I can just double click on that account and change the password here as well if I like. And then we see here, for example, I just changed his group membership. If I go on down here, we see that he is now indeed a member of, if I can get there, the users group, whereas he would have been a member of the Tony group by default earlier. And of course, other things I can do here if I want, I just add Tony back in if I want, just by checking a checkbox next to that name of that group as well. Other things we can use, I guess I should have left that open, is I can go in here and I can enable count expiration. For example, if it's a temporary worker, I only want him to be, working within my corporation for a certain number of days or so on. I can enter in that kind of information as well as password expiration information that is self-explanatory here. Also, if I want to delete the account, I can select the account here and choose the delete key up on the menu bar up there at the top, or I can also just delete the account here as well. User delete, Tony, enter. Let me get out of this. Then if I refresh the screen here, we'll see that Tony's account has indeed been deleted. Now what we're going to do in a few moments here is to just quickly install a little bit of software so you can see how to do that as well. But I've got some software files on a CD-ROM, and yet I can't access them yet. Well, for example, if I were to go over here to minimize this. If I were to go to my trainer's home and go up in the file system, I would try to go down to the MNT directory and then to CD-ROM. But there's nothing there, even though there actually is a physical CD in the tray right now. So what I need to do is to mount that. Now, before I type in the commands here to show you how to mount a CD-ROM, let me point out that many distributions of Linux will automatically mount the CD-ROM when you insert the CD. But if it doesn't, you might need to know how to do this manually, and this is exactly how we do that. And I'm just typing in the commands here, ISO 9660, and I'll explain these after I type them in. Okay, the mount, of course, is self-explanatory. It's going to mount it, but the ISO 9660 item here is just a reference to the standard, the ISO standard for CDs and CD mountable media. And then there's dev, that's our device directory. It's pointing it to the CD-ROM, and it wants to mount it to the MNT CD-ROM folder. And so that's how we'll be able to access the contents of the CD-ROM is through that folder instead of like a drive letter as we might with Windows. And once I press enter, then it's going to go ahead and mount that read-only media, which of course CD-ROMs and CDs are read-only. And then if I want to confirm that, I'll just change directory to MNT CD-ROM, and I can do an ls, and we see all different kinds of files there that are on that CD-ROM right now. If I want to unmount that CD-ROM, then I'd have to change directories because I can't unmount it while I'm in the same directory as the CD-ROM. So I'll just go, CD to the root, I guess, for example. And then I'll just umount. It's kind of weird spelling. You'd think they could have afforded to put the N in there in the command, but unmount is spelled U-M-O-U-N-T here. And then you can enter in either dev CD-ROM or MNT CD-ROM. Either one will work. And then once you unmount it, then it will no longer be available. I'm going to actually go ahead and remount that for now because we will be using it, like I said, to install some software. And before we get too far along with actually installing anything, let's take a quick overview first of all. One of the things you'll want to understand is that a lot of the Linux software packages that you'll want to install are going to be compressed, which of course makes them easier to download or to transport to other people. So the compression is typically going to be a zip format, or you can use gzip. They're both very common. A zip format file will end in .zip typically, and a gzip file will typically end in .gz. You can also archive the files. Typically, we're going to be using something called a tar file to do that. And this is simply going to be something that we can, not compress, but we can collect a bunch of different files and directories into a single file, again, to make it simpler. And then if you want to do a combination of both compression and archiving, you can use something called a tarball. This is where it's going to both tar the file, and it's going to use gzip to zip the file up. So you wind up with a tarball there. If it doesn't work, I suppose you wind up with a hairball or something. I don't know. Anyway, you also have these common file extensions .tar. Again, there's going to be a tarball file. RPM and deb, what are those? Well, those are relative to specific distributions of Linux. RPM is Red Hat Package Manager, and Deb is for the Debian distribution of Linux. Now, it's conceivable that I could take a Deb package and open it and install it on a Red Hat operating system, and likewise, I could take a Red Hat Package Manager file and open it and install it on a Debian Linux distribution of the operating system. However, typically we don't do that. We stick with Debian packages on Debian, Red Hat Package Manager files on Red Hat. And then another reason why a lot of people like Linux is because of the flexibility of it. You can use make to compile your own programs. And this gives Linux users a great deal of flexibility in what they do. For example, they might have some kind of freeware, shareware, or other Linux distribution of a software application that's usually pretty open, and you can add components to it or remove components from it and so forth, or make your own modifications. And then you can use the make command to recompile it. Now, this is also going to be hacker sensitive because hackers will often decompile and recompile their own applications that also include some kind of a Trojan or a virus or some kind of spyware or malware included in that file. So that's another reason why, another reason why Linux is attractive to hackers. All right, we can see here then that I'm going to now copy from my CD-ROM, which I've mounted. I'm going to copy a program called ceh05, and this is the version of it, and it's Red Hat Package Manager file. And I'm going to copy that to my USR local, my user local location on my local drive here. So I'm going to copy it there because I want to then use RPM to be able to decompress and install this application. And then now you can see that I've gone ahead and changed to the directory, the user local directory, and I've listed to see that I do indeed have the ceh05 application here, the Red Hat Package Manager file. So I'm going to go ahead and type in what I need to do to install the Red Hat Package Manager file. I'll just type rpm-i, and I'm going to install ceh05, and I press tab to enter in the rest of the item. Once I've done that, I'm going to press enter, and it's going to give me just a warning sign. That's okay. It's just giving me some information about the installation, and I can see this program actually work. Now, if I type in ceh05, I can see that it does give me the application and all of the additional parameters or options that I can use when I run the program. And ceh05, by the way, is an application that you use to be able to determine a remote operating system. That's a big key in hacking. You need to understand what the remote operating system is that you're trying to hack so that you can then search for the appropriate exploits against that operating system. What this does is it sends TCP packets to the destination, and it sends them in a variety of different ways, and different operating systems will respond in different ways. That's what we use ceh05 for. So in any case, if I were to use ceh05, let's just look at an example of how we might use this. ceh05, and then I might do it, the host, which let's just give it 10.10.10.5. I think I've got a system open down there. And then I can enter in -p for port, or I can just leave it at the default, and it's going to query against port 80. So I'll press enter here. Now ceh05 is going to go ahead and search out that particular port. And then offline here, I just went ahead and ran a couple of other ones here. I did try to run it against 123 as well. Port 123 is the network time protocol port, and so if this particular server that I'm querying against, if it goes out to look for the accurate time, for example, to get the correct time from an atomic clock, then it's going to open that port up. Apparently that one's not open on this machine. I opened up 445, which is a common Microsoft port for Active Directory, and again I was able to get the same answers back. It thinks that there is a Cisco device in there somewhere. In reality, this is not true. And this is just one of the things that you'll find with ceh05 and other applications. And this is, again, what's going to separate a real hacker from a script kiddie. A script kiddie would just look at this and say, okay, I guess I'm going to attack a Cisco box or a Cisco router of some kind or something. That's not really necessarily the case, because what a real hacker is going to do is they're going to use multiple tools to try to confirm their results. They're going to be able to read the tools correctly and accurately, and to get a better idea or a better picture of what they're really up against. Now, later on, if you need to uninstall an application, for example, maybe I've decided to use another product besides ceh05 now, then what I could do is to do an rpm-e, ceh05 in this case, press enter, and now the program will be gone. If I try to run it again, no such file or directory. In this nugget, we addressed using Linux. We started off with a brief overview of the Linux operating system, why we might want to use it, what its advantages are. And we also took a look at the basic usage of Linux, how to log in as root, for example, how to get a desktop operating system running if you want to use the desktop, for example, using something like GNOME or something like that. Remember, you just use Start X to start the X server. Then we also took a look at some of the common commands we'll use, especially for things such as file management, as well as commands that you can use to create, modify, and delete user accounts. And of course, there's also a user interface to do that as well if you like. Then we also took a look at applications. Remember, there's a couple of different ways of installing applications. You could use a tar file or a compressed tar file, which would be a TGZ file, by the way, or you could use Red Hat Package Manager, which is quickly becoming one of the more popular ways of doing that because it's just easier. And then there's also the Debian Package Manager as well, which you would use, of course, in a Debian distribution of Linux also. Well, I hope this has been informative for you, and I'd like to thank you for viewing.